I take privilege to welcome our National Council members, past Secretary Generals, all chapter chairmen, all secretaries of the past chairman and secretaries of the respective chapters. I also welcome the professionals from the industry, policymakers, and I also welcome professors and students from various universities who has been the maximum in number in the participation. I welcome one and all for this webinar on innovation through startup in mining and mineral sector part 2. Because it is called part 2, we had another webinar on innovation through startup in mining and mineral sector on 23/8/2020, for which we had a very good response. In this webinar, we are going to have the speakers. I wholeheartedly welcome them. Firstly, Mr. Sunil Vedla, CEO, founder, Nano Precise Corp, Canada, who will be speaking on practically reliable value, value of automated productive and prescriptive maintenance for mining sector. Welcome you, Mr. Sunil Vedla. Next is Mr. Anirudh Reddy, CEO of Insight, who will be speaking on mission vision analytics to boost mining productivity. Welcome, Mr. Anirudh Reddy. I also welcome George Pedrals, President of Mining Policy Commission of Institute of Chile. He will be speaking on startup from a dream and hope to mining to a public policy. Welcome you again. I welcome Sri Srikanth Mishra, Senior Research Leader, Battelle Memorial Institute of Columbus, ESA. He would be speaking on role of startup in the oil and gas digitalization ecosystem. I welcome Victor Chavez, CEO founder Rio Analytics Brazil, who will be speaking on applications for predictive maintenance in mining, oil and natural gas industries. So this webinar has been will be is going to be very useful for the students, and it will be thought provoking for the professionals, and I am confident that it will be very useful for the students. So far the participation registration has been very good, and I hope it will be a very grand success. I wish one and all who joined this webinar, thank you, and wish a grand success to this webinar.
So I extend my hearty greetings from Hyderabad, India, as all the speakers are from different parts of the world. And Hyderabad is known as the city of the Paul. And MEAI shines like a paw among the professional associations of mining and mineral sectors in India. Mining Engineer Association of India is very active. And as Mr. Narsaya has already told that this is the second part of the international webinar on startup in mining and mineral sector. Startups are the prime mover for the growth in any sector, and mining is not separate from that. And last time we have seen a lot of encouragement from the audience and the participants, and that led us to organize this seminar where the speakers will be from different part of the world. It is there from Canada, Chile, USA, and all other places. Last time we have seen that the startups in 4 countries like USA, Canada, Chile, and Australia, they have done very well, and about 68% of the startups are in those countries. So that prompted us to cover all these countries from the western part of the world. I again greet all the past presidents, council members, mining professionals, students, and all the participants who have already joined. I would like to say that the proceedings will be like this. The speakers will be given 20 minutes time to speak, and after 15 minutes, we will be putting an alert so that the proceedings are run smoothly. And there will be a question answer session at the end of the summing up by Mr. Sushil Kumar. However, we have given a link. Our tech team has already given a link to each those who have registered. They, through that link, they can send their question answer to the particular speaker or to the everyone, so that it can be answered at the end of this session. And our president, Mr. Sanjay Patnaik, has already been there with us. He is a guiding force for all the mining engineer association activities in the country. He is not only is the guiding force, he gives a lot of encouragement, and he has brought MEI to a digital platform after this pandemic has set in. And I wish everyone to be safe and healthy wherever they stay. And I now request Mr. Sanjay Patnaik to give his inaugural address. Over to Mr. Sanjay Patnaik.
Good evening to the participants from India, and greetings from the Mining Engineers Association of India for all the participants who have joined from different parts of the globe. Mining Engineers Association of India feels overwhelmed with the participation of such large number of students, a large number of people from across the world, from various countries, in this international webinar, innovation through startup in mining and mineral sector, the second in the series of webinar that we are conducting. On behalf of my own self, on behalf of the Mining Engineers Association of India, I extend a very warm welcome first to the very distinguished panelists that we have, Dr. Srikant Mishra, Mr. George Pedrals, Mr. Sunil Vedula. We also have along with us Mr. Anirudh Reddy and Mr. Victor Chavez. Welcome once again, gentlemen, and we are happy that you have accepted our invitation to be part of this webinar and share your knowledge with the participants. I feel very happy that large number of students have participated. I'm told that about 37-38% of the participants are students and from academia, and about 40% from industry. Last webinar, the first in the series, when we had it on 23rd August, similar kind of participation had taken place, and we also had some great panelists at that point in time. Special welcome to all my colleagues in the MEAI, the former presidents and senior members from the industry. We feel privileged with your presence, and we feel encouraged with your presence and all. Mining sector in India is actually at a at a point of inflection, as I often say, because the mining sector has to significantly contribute if our country has to achieve its targeted GDP. The mining sector has, looking at the potential of the mining sector, it has not been contributing the way it should. But with the structural reforms that government of India has taken, with many changes, policy changes that has come in, for example, allowing commercial mining, coal was nationalized, and there was no private participation in coal mining except a few coal mining as well as commercial mining of coal. So that has been allowed. We have in exploration, private sector investment has been also allowed. So all these big time reforms in the mining sector actually would contribute largely to the growth of the mineral sector and the mining professionals in the country. So I feel that at this point in time, if the Indian mining sector has to grow, innovative practices, innovative approach has to be practiced. And there is a tremendous scope for startups in the mining sector. So it's very appropriate for the Hyderabad chapter, which is one of our key chapter, led by Sushil Kumar, its chairman, who has, I must say, who's been very enthusiastic and has been sort of driving these kind of initiatives in Hyderabad chapter and in particular and the Mining Engineers Association in general. A lot of activities on this. He is also the chair for our policy reforms, in the sense that whatever policy matters that we represent to the government and all that goes through him, and he scrutinizes that, collating from every chapter and all. So I'm very happy that this webinar is taking place. I'm very happy with the kind of topic that has been chosen, and I wish that with the knowledge that would be imparted from across the world, the best practices from across the world, our mining sector will stand to gain. So we look forward to hear from the speakers. And thank you very much for giving me this opportunity. And thanks once again on behalf of Mining Engineers Association of India to all the participants, to each and every participant who have joined. And over 700 participants joining actually has made us feel very, very encouraged, and we are overwhelmed by your presence. Thank you very much.
Thank you, Mr. Sanjay Patnaik, for your inspiring address to the participants and to us. The technical program will follow after this, and we are very much sure that it will be very interesting and very interactive, and people who are joining through online, they will be watching it. And we know someone has said very recently that anything nature takes from us, it gives us also something. So this pandemic has taken many things from us, reduced the growth. However, this platform has been given to us, and now the whole world has become closer. The five eminent speakers who will be following after this. We know that the startups provides consulting, exploration, project management, mine management, audit, financing, and all other aspects of mining. And last time we have also discussed that why the conventional mining owners will continue doing everything. Why not startups give them innovative ideas to reduce cost? Because cost cutting is one aspect which needs attention now after this circumstances becomes normal. Or we call the new normal has become actually normal. I invite next speaker, Mr. Sunil Vedula, who is from Canada. Mr. Sunil Vedula is the CEO of and founder of NanoPrecise, a company which deals with condition monitoring system. As you are talking about the cost control, condition monitoring system is one aspect which will reduce cost. He is the founder of this NanoPrecise. To briefly mention about NanoPrecise, it provides an IoT-based condition monitoring system that acts like a machine doctor. This system not only detects an anomaly in the system, but also predicts mechanical faults related to unbalance, misalignment, looseness, bearings, and all in gearboxes. So this NanoPrecise has created a unique patent pending solution called Rotation LF. This Rotation LF combines physics, material science, and data analytics and diagnose issues with rotating equipment. And as we now all know that youth are the strongest asset to any country. And when you see him, he is very young, and his dream is very high. And he is not only working or operating in Canada, he has come to India, and he's operating rotational LF is now operating successfully in many processing industry in India, like Hindustan Zinc, at Chandriya lead zinc smelter, and also he was getting work done at Tata Steel. So I now request Mr. Sunil Bedula for his presentation, which is already on the screen share mode. Now over to Mr. Sunil Bedula.
Thank you, Dr. Nanda. Thanks a lot, everyone, for this opportunity. And so at NanoPrecise, what we are trying to do is completely automate the condition monitoring, especially for rotary machines like pumps, compressors, and motors. So this presentation is about practically realizable value of automated predictive and prescriptive maintenance, especially in mining sector. So first, we need to understand what are the different types of assets and why rotary machines condition monitoring is so important. From the data achieved from a very reputed institute called OREDA, which is formed of the top 10 mining and oil and gas companies, it's clear that the rotary machines are the one which have the highest failure rate. And for compressor, it's as much as one compressor is failing every 250 hours. So that says that we need, for any company in mining or oil and gas, compressor failure or rotating failure is really a pain point. And that's why we need to address that first using condition monitoring. So what exactly are the issues in the industry? McKinsey report says that $100 billion per annum can be saved in unplanned downtime all across the globe just by having proper condition monitoring and having repairs or insights ahead of time. But the real issue has been the fact that it's not like there are no solutions. There are many solutions in the market for this. The approach is something that seems to be an issue. And because of this, the Cisco study has said in 2017 that 75% of the predictive maintenance projects have failed. And the factors listed for that is either data inaccuracy, data insufficiency, or inaccurate feature correlation. And all of these leads for a relation between a PDM vendor and the mining company to be stuck in pilot purgatory and doesn't expand too much and leads to delayed implementation. So the main reason that we have identified is assumption by many companies that measuring process parameter variables can help help in equipment monitoring. But what we have found is it is just like going to the doctor and expecting the doctor to tell me my health just based on what I am eating, how much I'm breathing, and all that. But rather, the doctor focuses on the system response variables or output variables like the blood rate and all that. So in this example, what I mean by that, we need to measure things like vibration, acoustic, magnetic flux, the surface temperature, rather than process variables like pressure, temperature, and flow rate, as explained in this diagram. So you can see that there are input variables are flow rate, temperature, pressure, and the output are these ones. What we have found is output variables are the ones that are not range bound and are increasing over time. And those are the ones that really help. So that's why either we have the equipment vendor should have a very high resolution IoT device. And if they don't have, then an IoT device is needed externally to really achieve this kind of smart condition monitoring. So what are different objectives for efficient management of any machine? Like even if it is your car, right? If you're driving your car, two things can be done to efficiently manage that. One is process optimization. Like when you're driving your car, you can actually make sure that it is, you're driving efficiently. So to see if your car's economic mode button is on all the time or not, right? And if it is, if it goes beyond economic zone, you reduce your speed so that the car comes back. That's one way of efficiently managing it. And the second way is that whenever you get a maintenance due symbol in your car, that an oil change is needing, and that's what is called predictive and prescriptive maintenance. So to know in advance and to go to the mechanic before some failure happens. So in this presentation, we are focusing on predictive and prescriptive maintenance. So four major objectives of any predictive and prescriptive maintenance. First, to know if there is anything weird in the data from the sensors. Second, if there is anything weird, that does not mean there is a problem. That needs to be understood whether it is really the problem with the machine or just the normal operation, like fluctuations in the normal operation. So the second objective is fault mode determination. Then comes, okay, well, the fault has been identified and there is a specific component inside the machine that is going bad. When do we notify the customer? Because notifying the customer too early is a problem, too late is a problem. So for that, estimating remaining time to failure is very necessary. And finally, for example, one component in a machine is failing every now and then, that does not mean that the problem is with that component. The component is just a side effect. The real reason or root cause is somewhere else. So how to find out that root cause? So these are four basic objectives of any predictive and prescriptive maintenance. To solve this, we are coming up with a sensor plus software end-to-end solution. So our sensor is called Machine Doctor, as explained by Dr. Nanda, and it is one of the only sensors in the world that can detect vibration in 3 axes, acoustic emission, how the machine is sounding, the surface temperature, how hot it is becoming, uh, RPM, so at what speed it is running to create that vibration and noise and have the temperature, and humidity, in how much humid environment is it, and then magnetic flux for especially for motors, because as you know, motors work on electrodynamo principle. So when the motors go bad, their magnetic flux or magnetic field increases. So magnetic flux helps in determining if the motor is going bad. So with one sensor, we can detect all these 6 parameters. No additional sensor. Apart from this, this sensor is certified for all the hazardous areas, has IP68 waterproof. It's even better, even good for nuclear reactor, because it has IEC EX Zone 0 compliance. So once this sensor sends the data to the cloud, okay, or even to either private cloud or the public cloud like Azure or Amazon AWS. So what happens? First thing is, before at the start of any project, we take the equipment details, and these equipment details are not very difficult to get. I mean, usually our users, they can enter the equipment details through an app, right? So it takes hardly 10 minutes for them to enter for one machine. They can just click the picture of the machine spec and just upload the picture, and we have the details for thousands of machines. So from there we get the actual equipment detail. And so when the sensor data is arrived in the cloud, these 6 parameters that we measure, those sensor data are correlated with the equipment details, and very sophisticated artificial intelligence algorithms are performed to basically achieve four objectives, 3 objectives that I mentioned: anomaly detection, fault mode determination, and remaining time to failure prediction, all in a completely automated manner. And if there is any untoward incident, it is notified to the customer through a mobile app, either iOS or Android based. So for the fourth objective, that is automated RCA, which I consider as one of the most important and like a long value generating objective. For that, we can also get data from customers' existing sensors or DCS, PLC, and SCADA. It doesn't need to be from our sensors only. And though we correlate them with our sensor parameters and equipment details to again conduct and find out the root cause, not just the component that is going bad. So how are we really different? First is the high temperature compatibility. Our sensors are high temperature. Second, I can quickly show you how the machine actually sounds. So basically, the users can also hear how their machine sounds. Why this is so powerful is when we send a notification to the customer, they can actually listen to it. In the beginning, how it was sounding, like we send one big sound sample, let's say a day, so they can listen to the sound sample. What was the sound of this machine when in the beginning, the first day when the sensor was installed, and what is it now after 2 months? So they can compare that and see, oh yeah, there is some problem. So what nano precise software is saying is actually right. So this is a very powerful way, and the users does not need to understand our AI. They can actually intuitively believe that there is a problem and then go to the site. So the next step is a vibration to RPM correlation. So this is also an important parameter, because just imagine you have a car and you're driving on the road. All of a sudden, you started driving very fast, right? And if you have our sensor, so if you don't know the speed, what will happen is at higher speed, it can have higher vibration. At lower speed, it can have lower vibration. So we need to understand the speed of the machine to really see, to really differentiate whether this increase in the vibration is because of the process fluctuation or the speed fluctuation, or is it actually because of some internal fault. So this needs to be done to really get rid of false positives or not so useful notifications. The next is magnetic flux for electrical faults. Apart from that, we have different versions available for the power and connectivity. If some application needs electrical version, we have electrical version. Otherwise, we have wireless version. If you want Bluetooth, we have Bluetooth version, or we have 802.11 AC now, which is the most powerful Wi-Fi available. It is also good for most of the surface mounted sensors are good for only anti-friction, but our sensors, because it has the acoustic emission and the RPM, it is also good for anti-friction and journal bearings, because journal bearings machines are very, very expensive, and the failure happens very catastrophically. Once a small failure comes in journal bearings, the damage can happen within 15 minutes. That's it. So our unique process is basically it's about our process. That is what makes us unique, the software process. So starting from the step one to detect, first, as I said, the three basic objectives: anomaly detection, fault mode characterization. So for the step one is anomaly detection. We use basically only acoustic emission and temperature for that. The next step is once the anomaly is detected, the process. So there we use very advanced signal filtration technique. This signal filtration technique is so advanced, you can imagine it like this. If there are 50 people sitting in a crowd in a room, all of them are talking together. When we take a voice of this crowd and apply our filtration technique, it will filter that one crowd signal into individual 50 persons signals, and we can understand who all was there and understand their severity of talking and all that. So that's what we're talking about. So that is used on the RPM and the vibration data to do the second objective, which I said, fault mode determination. And finally, the third objective of the remaining time to failure prediction, because user is really interested into that okay, tell me how, in how much time I should take an action so that I can avoid any unplanned downtime or any interruption to my activity. So that is the fourth method, and we use the fault mode severity for that. And finally, we confirm it with temperature reading. So coming to, as I said, there are many solutions available, but not all automation is equal. How? So there are multiple levels of automation. As I said, 70% of the market is still manual data collection. Analyzer technician has to go to the site and take an analyzer and take a reading, come back to the office, do an offline analysis. All this is not really needed anymore. So the next step is, okay, now instead of doing manually, I will just collect the data. Okay, automatically collect the data, and but I will do the analysis offline, manually. Okay, that also is not complete automation. That is only second level. The third level is, okay, I will collect the data automatically, and I will also do some anomaly detection, but I will not do the fault mode and the remaining time to failure. That's the third level. The fourth is, okay, I will do the anomaly detection, but I will do the fault mode characterization automatically, but I don't want to tell what is the remaining time to failure. So that's also only fourth, because the customer needs to know exactly, in or at least a reasonable estimate, right? Like, just imagine you go to the somebody goes to the doctor, and doctor says that, oh, you have a very serious problem, and there is a cancer. And so the natural reaction from the patient is, doctor, please tell me how much time do I have, right? So that's why automated remaining time to failure is important. And I'm glad to tell that nano precise software is achieving the level 5 automated remaining time to failure. That means it has already automated the previous levels, and that really helps in avoiding, increasing our probability of avoiding unplanned downtime. So when we compare ourselves to the regular, current manual data collection methods, we see 36% cost saving just for 100 semi-critical machines, right? And it not just that, it also increases the safety and reduces the need for the mining company to have a need for specialized technical resources on site, 24/7. So that was compared to the offline condition monitoring. But when it comes to the other softwares which are which are doing automated data collection but not automated fault mode determination and the remaining time, so we even there we see a difference is almost 6,000 hours per year of automating the so basically in total, what we have seen over that method, we have three times like a 66% reduction in the price, in the overall pricing compared to the just the automated anomaly detection, and that leads to 3 times more ROI. So coming to the case study, okay, so we generated few really good case studies with Nutrien, a company in Canada. So where there we saved $720,000 in value by detecting a bearing in advance on a very important pipeline, like a potash production pipeline. And the customer, these numbers are actually coming from the customer, not from us. Similarly, in Tata Steel, we are conducting the biggest IoT project in India, with 1,000 sensors installed, and we saved, we recently, just in September only, we detected a gearbox failure, and it saved $80,000 per hour for the customer for and that lead to almost like to $400,000 in savings. Coming to our actual mining case study, so we are working with Caterpillar on multiple equipments. So what we do, as I said, we can detect RPM and vibration. So we were able to correlate the RPM with vibration and detect the inner bearing fault, and that again led to $150,000 in savings. This case study is very complicated because the speed is always changing during the operations. So it's very important to understand the speed to vibration correlation and separate out the load fluctuations from this. Through this approach, we have gained customers in almost every zone now: oil and gas, pharma, mining and metals, and fertilizer. And we have distributors all across the world now, including markets like Japan and Australia and Nigeria, apart from North America and Europe and Asia. We also have in Middle East Asia, because we understand that we cannot implement everywhere by ourselves. So that's why we train our distributors. So some key metrics. One thing that we are very proud of is that more than 90% of our customers that have done pilot projects with us have converted to actual contracts. Second, we have now more than 2,000 plus trade sensor licenses across North America and Asia. Our average contract size is $70,000, and with a minimum contract duration of 1 year. We have, as Dr. Nanda said, 2 offices spread across 2 offices, and India is our very important development center with almost 24 employees that supports our Canada office that has 7 employees with all the subject matter experts. Thank you.
Thank you, Mr. Sunil Bedula. It's a very interesting and highly. George Federals is the president of mining policy. He is from Chile, and we know that Chile is a country in mining, a mining rich country, which does a lot of mining, and mostly it is known for its copper mines. Mining, home to some of the world's largest better known copper mines. Approximately 80% of the Chilean production comes from copper deposits. And Mr. George Predal is the president of the Mining Policy Commission of Institute de Engineers de Chile, member of the board of Institute de Engineers de Chile, and he is a basically civil mining engineer and Universidad de Chile and master in history. It's very interesting that he's a man from history subject with 35 years of experience, in which 30 years he has been key management positions. He led as the chief executive officer for the last 10 years 2 projects in coal open pit mine, port facility in a remote island called MEAI in Verino. And he was also associated with a $4 billion project, which is underground mine in the world owned by Codelco. Highly experienced in leading projects and work teams, strongly oriented for results in environment and high security. And I am really happy to see him again, because he was also my co-panelist in the digital conference MindSafe in Australia in September. I welcome Mr. George Pedals. Now, Mr. George Pedals, it's over to you. Thank you.
Thank you very much for the invitation, and it's a pleasure to be with you in India. It's funny, as you said, Dr. Nanda, we were together in a forum in Australia 2 weeks ago, and now we are in India talking about the startups. Well, this presentation is related to public policy, and the name is From a Dream and a Hope to a Public Policy. Well, all the opinions here are my sole responsibility, in spite of I'm the president of the Mining Policy Commission of Instituto de Ingenieros de Mina of Chile. Well, this is our agenda. We will see these topics. Some of them I will pass very quickly. You can go further on later on some of them, and we will start looking at where we are and what is Chile in the mining industry, a definition of a startup, according to a consultancy company called JIM, a comparison between Chile and India startup ecosystem. We will see with some details a startup context or ecosystem. I will mention the Chilean state program regarding a startup, and in the presentation there are some results of this program. We will see the post-evaluation of this Chilean state program. There are also some information of mining a startup program in Chile called Expande. You can go through some details that I will not show in detail in the presentation. I will mention the Antara case. Is a software company giving assistance to mining industry in the north of Chile. And I will go with some details in these question answers and barriers regarding a startup in the mining industry. And I will finalize with the state, a vision of the whole in order to try to project into the future. Well, Chile has a population of almost 20 million people. We are very small if you compare with your country. And we have a GDP per capita of almost $16,000. 48% of our exportation are related to mining products. Chile represents almost 30% of the world copper production. So we are very important regarding copper production around the world. The mining today represents around of 10% of the GDP. And the highest figure in the last 20 years was something around 21% of the GDP in the country. The mining taxes are the most important taxes in Chile, excepting VAT. The mining taxes in Chile is equivalent to the add of many other activities. It's a very nice country with a very nice sightseeing. In the north is desert, in the central is a very green country, and in the south we have a very nice mix of mountains, ice. Let's see this GIM comparison between Chile and India startup ecosystem. This GIM has a chapter in this city of India, and here you can see the comparison between Chile and India. Chile is the blue and India is the orange, and you can see that the ecosystem in India is slightly better than in Chile. And of course, I think the size of your country gives some advantage. So if we have good results in the startups in mining, sure that you can get a lot better results in the startups mining industry. Let's see the startup context or ecosystem. The ecosystem, you need knowledge, capital, and companies. Three are key for the startups. And the startups needs to get into maturity stage, selling their products or services. And for that, they had need to make a product industrial launch of their products. There have to be done a definition of a minimum viable product with testing and validation, and everything this started with a concept. And in order to accomplish these goals, you need to be connected with knowledge, capital, and companies. And this is the big challenge for the startups. And of course, you can have private and government agencies in order to help the startup to be connected with this knowledge, capital, and companies. And it's important that you understand where you are, because if you want to produce a very high impact and you want to be related with the core of your customer business, and you are trying to launch a very complex product, you must be dealing with complexity. And I like to say that dynamic complexity is the only way to understand and manage companies and problems in the society today. We will see at the end a definition of dynamic complexity. In this graph, you can see one of the effects that you can get from startup companies. With the startup companies, you can jump in a new scenario of production, and you can get more productivity, and you can get innovation in the production in every industry. But you must have into account this graph. Here you have the entrepreneur activity rate, and here you have the per capita gross domestic product. Depending on where you are as a country, you will see that in the lower part of this graph, you have the startup has an opportunity to overcome poverty, for example. But in this part of the graph, when the countries are richer, the startup is an opportunity, business opportunity. So depending on where we are, you can see that a startup can help you in order to overcome poverty and other society problems, or to be an business opportunity. The Chilean mining ecosystem is very rich, has a lot of different actors playing the game. And finally, I want to mention especially this expanded program that is a group of companies, mining companies, a bank, consultancy companies, and agency, governmental agency that is helping in the startup mining industry. The Chilean state program regarding a startup started in 2010, and with some objectives. Here you can see some information. You can go through this presentation. There are other slides hidden now, but you have more information about this startup program. And what was the post-evaluation of this Chilean state program made in 2015? The startup program started in 2010. Well, the program didn't have a statistically significant impact in the project, and maybe that was related that it wasn't based in a logical framework approach, and it's very important in public policy to be stick into a logical framework approach. In spite of that, in accordance with Corfo, this is a governmental agency, in 2020, there are almost 2,000 startup companies, whom 47% are active, and they have raised $2 billion. And this Chilean program helped to improve the ecosystem of the startup in Chile. And the recommendation of this post-evaluation was related to stick to a logical framework matrix and define a very clear and sole purpose in order to be able to measure the result of the program, particularly if there are some funds related to the governments in this kind of programs. Also, you can see a lot of information that are in other slides that I will not show now, but there are a lot of information, and the importance of this expanded program is a mix of mining industry companies with other companies promoting some challenge that they need to address and giving room for the startup to growth. The Antara case is one case. This is a software company that started in 2012 in the north of Chile. They have today 8 years of a lot of problems and challenge, and now they are very proud to say that they have growth 30% each year. Last year they grew 130% in people, and today they have more than 4.4 million tons and $23 billion in product managed. But if you talk to the founders of this company, he feels that he continue managing a startup, challenging many different challenge in their everyday life. The importance of this startup, of course, is not only innovation, is that you are giving employment to many people. This guy is the founder of this startup. Let's see with some more detail question, answers, and barriers related to startups. From the point of view of the startups, you can have four different perspectives, at least four different perspectives. The perspective of the entrepreneur, he's looking these three aspects, knowledge, capital, and companies, not necessarily very close of them, with a lot of difficulty in order to understand these three things. You can see the startup challenge from the point of view of a private or government agency in order to try to facilitate the life of this entrepreneur. Or maybe you are in the middle of a company that is looking for some solutions that you cannot find with your own people. And finally, you have the perspective of the state, the big picture of the startup problem, regarding in what country you are, and regarding how rich is your country, and maybe the startup are an opportunity business, or maybe is a process that you will use in order to enrich the social network of some region of your country. Some potential questions of the different actors. From the point of view of the entrepreneur, you can have a lot of questions. What, why, where, whom, how, many questions, has people that are trying to launch different ideas. Point of view of a private and government facilitating agencies, if you consider the private sector, well, each actor will define their own questions, considering that there is a market, and there is a specific environment that you are living in. From the point of view of the government or the local county, it's very important that you have very clear in your mind what are the final and specific objectives that you are trying to reach. What are the wanted results and the action plan? And from the point of view of the mining companies, why and for what I need the startups, and what do we win with the startups? Well, some answers. Well, you cannot give all the answers to the entrepreneur because they are too many, but you have to understand, define, and nurture the ecosystem. From the point of view of the private and government facilitating agency, well, you have to be careful with the incentive, if there is any incentive, because there is a market and profit. So information and education is crucial because there is some asymmetries in the market. From the point of view of the government or local county, you have to think that you are trying to improve some market failures. So you have to define very thin and focused organization with the help of a specialized non-governmental organization. And the answer for the mining companies, why they need startups, well, is related that they will get the social license. It's a way to get a knowledge and acceptance from the community. You will get a healthy and start. Some of the barriers: mining, production, continuity, key assets. Well, here you can see the barriers, 8 barriers at least. And finally, the state of the vision. Through the startup, you can enrich the social network in the counties and in the country. More value, more education, more culture. How we build with cultural landscape, managing with dynamic complexity. And here you have the example of a coal mine where I was the CEO, and you can have the mix of wildland, rural, and urban. When you build a company, you will build in a specific way. You don't miss that you are trying to understand the whole. And for example, here you can see 8 different perspectives in order to build a public policy regarding the startups. If you choose only 2 or 3 of these perspectives, you will get a very different solution, and you need to focus looking at this eighth perspective. From necessity, innovation arise. Difficult situations are those that make you extreme and make you get as creative as possible. From a dream and hope, transform it in a public policy. Thank you very much.
Thank you very much, Mr. George. It's a brilliant and a robust presentation. You have given a overall scenario of the startup ecosystem of Chile. That is very interesting to know in India. And the participants who have joined from academics, who have joined from industry, they must be realizing how the Chilean government is helping startups, and also the dynamic complexity, how it has been getting resolved, and your the conclusive picture when that the jumbles has become a cycle. So a startup is like that. In the initial time, you need not be worried much. You should start the things with your ethics, economic things, innovations, and then it automatically grows, and it becomes a, not automatically, I'm not saying automatically means you have to put a lot of effort, and it becomes a cycle and it runs. So it's a very interesting presentation. I think all the participants will be very much inspired by your presentation. Thank you very much for joining us, and I hope we will be again joining as we are moving from east to west, and sometime we will join in Chile. Thank you very much. Thank you very much. I now invite the next speaker, Dr. Srikant Misra, who is a senior research leader at Battle Memorial Institute, Columbus, USA. He is a very inspiring career. He received his PhD degree from Stanford University, MS degree from University of Texas at Austin, and a BTech degree for our Indian School of Mines, Dhanbad, in petroleum engineering. After his petroleum engineering degree from Indian School of Mines, he started his work in USA. Currently, he is a senior research leader at Battle Memorial Institute, the world's largest independent R&D organization. He is a petroleum engineer by training, geoscience through leader by profession, and teacher by inclination. He loves to teach. He is nationally and internationally recognized for his 30 more years, 3 decades of contributions to data-driven understanding and communication of energy environment nexus issues relating to unconventional energy, oil and gas, CO2 geologic storage, and geologic waste disposal of nuclear waste. So, and he also is a serves on the technically advisor board of National Energy Technology Laboratory, popularly known as NETL at DOE, the Department of Energy, popularly known as DOE at USA, and leading initiative on science-informed machine learning for accelerating real-time decisions for the subsurface involving multiple national laboratories and leading US universities. Dr. Misra joined Battle in 2010, and after distinguished 20 years career, he has been working there and consulting and applied research, including appointments as Director of Waste Isolation Service at the Geosystem Consulting Companies. He served as a 2018-19 Global Distinguished Lecturer on a Big Data Analytics for the Society of Petroleum Engineers. He is also a member of SPE. Dr. Misra has also authored 3 books and more than 200 technical publications in his domain. So we are really very much happy to see him giving this presentation, and I think we'll be very much benefited by his lot of experience. So I now invite Mr. Srikant Misra to give his presentation. Dr. Srikant Misra, please.
Thank you, Dr. Nanda, for that introduction. So good morning and good evening. It's a pleasure to be here. I appreciate the invitation to be part of the distinguished group of speakers at this virtual webinar. So far, we have had two excellent talks, one which took a deep dive into the technology for predictive and prescriptive maintenance. And then the second one, which kind of took a different look at the startup ecosystem, particularly from the example of Chile. What I will be doing in this presentation is kind of thread the needle a little bit and talk more about the role of startups in the oil and gas digital ecosystem. As Dr. Nanda said, I'm a petroleum engineer by training, but my experience with resource extraction from the subsurface hopefully will resonate with mining engineers, and the examples that I have will be meaningful to you. So with that, let's get started. Here is the outline of my presentation today. I'm going to begin with some definitions, and then we'll talk about what exactly is a startup. Moving on to the topics of digitalization and a digital ecosystem. Then I will give some examples from the oil and gas sector. And in particular, I have 6 specific companies that I will be calling out in terms of what they do. And then I will end with some thoughts about how this can be applied in the mining sector. So let's begin with some definitions. A startup is a young company founded by one or more entrepreneurs to develop a unique product or service and bring it to the marketplace. Digitalization means we want to use digital technologies to change an existing business model and provide new opportunities for revenue and for producing value. An ecosystem traditionally is a community of living and non-living components that is adaptive, that is self-organizing, that is scalable and sustainable. So it is these attributes that we want to bring forth in the context of the application of digital technologies to our problem at hand. Now let's take a look at some of the key characteristics of startups. First of all, startups are very focused on growth. As you can expect, it's not just one person, it's more than one person. But typically, it's no more than 500 employees, meaning that the size is small. What is more typical is that startups work with technology and they're innovative, which means that they're not simply candidates that can be used for outsourcing of routine functions like back office support. You're really looking at startups which are small companies, which are agile and nimble enterprises to bring forth an innovative solution which is based on technology to an existing problem that has not been tried before. So a digitalization ecosystem is where you use startups in the context of bringing together enterprises, people, components, all connected by a digital platform. So, increasingly our systems are becoming more and more digital. Our people are getting more and more adept at using the power and harnessing the power of technology to solve their problems. Our components are getting more and more automated. So it's the connection of all of these through a single platform to solve our problems is what constitutes a digitalization ecosystem. Now, when we look at how exactly we can put a digitalization ecosystem into our advantage, here is some work done by the World Economic Forum in a paper written on digital transformation initiative. They basically highlighted 4 key digital themes, beginning with automation, robotics, and operational hardware, meaning how do we make machines work better? The second theme is a digitally enabled workforce, meaning how exactly do we make people interact better? The third theme is an integrated enterprise and its connection to integrated platforms, which means we need to know how to connect people and machines in an efficient manner. And then the final aspect is the use of analytics and decision support towards cost savings, towards efficiency improvement, and towards overall productivity improvement. So basically, here, our goal is to leverage the power of machine learning and big data analytics to understand hidden patterns and relationships in complex multivariate data sets and use that for better decision making. So now with that introduction, let me move on to some examples of oil and gas startups. So the first one is a company called Beyond Limits. They have a tool which is called Cognitive Artificial Intelligence for Oilfield Management. And their goal is to support operators in accelerating the integration of data and the analysis of data. So, in an early exploratory stage, when you're trying to figure out where exactly do you want to drill to maximize the probability of success in a new oil field, they can help pinpoint drilling decisions. They can weigh opportunity versus risk, and they can speed the time to decision making by basically harnessing the power of artificial intelligence while taking into account the extensive portfolio of similar projects that are available for that particular company. The second example is a company called Source Water. And what this company does is it brings data science and data acquisition technologies to increase transparency in the shale oil field water market. As you know, production from shale gas and shale oil wells has really pushed the US to be the world's largest producer of crude oil. And one of the big requirements for drilling and completing shale wells is water that can be injected at high volumes and high pressure to crack open the tight rock and basically create pathways so that gas can flow into the well. And so what they have done is that they have looked at where exactly the water can be sourced from, and this is based on data from satellite imagery, government databases, and Internet of Things. So not only do they have a platform for the sourcing of water, but because up to 70% of the injected water can come flowing back, what is the mechanism for recycling and the disposal of this water into deep saline formations? So now we move on to a couple of other examples where these startups are really helping companies in the operational phase of oil and gas production. So Novi Labs is a software company that is focused on the completion of wells, and these are once again shale wells. So how do you plan for and how do you forecast the returns from shale wells? And what that involves is doing cloud-based artificial intelligence computing with large multivariate data sets. And so this company helps producers make data-driven decisions on capital allocation, on well design, based on historical data from the same basin or from analog basins. Yet another company working in the same area is Tachius, and it develops production optimization software for oil and gas fields that are operating under water injection or steam injection to improve the productivity of oil fields that have been producing on their own for some time. So the Tachius platform, it uses historical data and builds predictive models which are based on machine learning and also informed by the physics of flow in porous media. And what this platform does is that its predictive models help reveal the best ways to maximize net present value and to lower operating costs. And then we have two other very interesting examples. The first is Nesh, which is a smart assistant for oil and gas. It helps make better decisions by organizing collective knowledge within the company and making it accessible, because it's really trying to say that there is information that is coming to us at a rapid speed, but at the same time, there is knowledge that has been developed within the company over a course of time. And that knowledge also needs to be harnessed so that we can take advantage of the institutional knowledge and wisdom and then use it to our advantage. So as the developers put it, think of Siri for the iOS or Alexa for the Amazon systems. And let's say you take Siri or Alexa and then took it to college and then gave them degrees in petroleum engineering and geoscience, and then sent them to work in the oil field for a few years. And then you also send them to conferences, ask them to read journals and books. So they will be almost like a walking, talking engineer or a geoscientist. And that is basically what Nesh gives you at your fingertips in the form of a question answer, interactive, dialogue based information assistant. Then we have this company called Data Gumbo, which was one of the first in the field to introduce the smart contract concept for the oil and gas sector. And the aim is to build an automated payment network for oil companies, service companies, and supplies, because their goal is to reduce delays and contractual disputes in the industry's current supply chain and transaction structure. So obviously, this is one of the areas where a lot of time can be spent in just making sure that the procurement process and the invoicing process work as planned, and then there are no bottlenecks. And if you can speed that up, then and also if you can automate that to some extent, you can improve efficiencies and you can also improve productivity. So with that, let me move on to some thoughts on the outlook for mining sector. We've already seen at least one presentation that goes into the details of how predictive maintenance can be applied in the mining sector. But here are some broader thoughts on where startups can really contribute. Let's begin with operational analytics, and this is where we're looking at the performance of integrated systems. For example, in an ECBM, an enhanced coal bed methane project, if you have a well field, you may want to apply analytics to look at what separates good wells and bad wells. You can also do the same thing to look at what separates a good mine from a bad mine. And then you can also drill down in terms of the relationship between the input variables and the output variables, as Mr. Vedula pointed out in the root cause analysis part, and identify factors that can improve performance. Then we move on to the second aspect, which is the intra-company knowledge base. And this is where the Nesh example is pertinent. So the knowledge base constitutes not just databases, reports, and spreadsheets, but also written reports, field notes. And here we can harness the power of natural language processing and text mining to abstract soft knowledge from senior staff to train the next generation of engineers and scientists. The third aspect is in supply chain. So perhaps we can build a better contracting process that involves the smooth integration of procurement and inventory management. And then in predictive maintenance, we've already seen one talk. We're going to see some more talks. So I'm not going to dwell more on that. But let me conclude by providing to you some key takeaways from this presentation. So the point I would like to make here is that there is significant opportunity for digital transformation by bringing together enterprises, people, and components through a digital platform. And this is where startups can play an important role because they are agile, they are nimble, they're innovative, they can keep pace with rapidly changing technology and bring that to the marketplace much more efficiently and much more effectively than large enterprises. And what we need is for startups to be successful is to get in a situation where startups are embraced on a more regular basis as enabling partners by existing larger public and private entities. So these are existing enterprises, whether it's Tata Steel, whether it's Hindustan Zinc, or whether it's IFCO, and typically they will not have the startup mentality, they will not have the startup functionality in terms of agility, in terms of nimbleness, in terms of innovativeness. And so the role of startups here is not only to provide technology solutions, innovative solutions, but also to be partners with these entities so that everybody can realize the value and essentially make the mining sector more productive. Now, let me end with this graph, which is called the Gartner hype cycle. Uh, and this slide is particularly addressed to the young professionals and the students who are listening to this webinar. These days, everybody wants to work for a startup because that seems to be the quickest way to get rich. But let me tell you that startups typically fail 90% of the time. 25% of the startups fail in the first year. A third of the startups fail in the first 2 years. That's because even though there is a technology triggered that gets the startup going, very quickly you reach the peak of inflated expectations in terms of what you can do and how much money you can make. And very quickly you fall to the trough of disillusionment. And this is where, within the first 5 years, 50% of all startups have failed. But then for the groups that endure and that persevere, they can go through the slope of enlightenment and reach the plateau of productivity. So this is 10% of all the startups that started out. So with that, I would like to wish all of my young professional and young student friends good luck in navigating the world of startups. There is a lot to be done here, particularly to advance the productivity of India's mining sector. And once again, I thank you for the opportunity to be here today. And thanks for your attention. So be happy to take any questions at the end of this session.
Thank you, Mr. Srikant Misra. You have presented very well. And I must say that you have also shown your proficiency as a teacher, because you were adjunct professor of petroleum and geoscience systems engineering at the University of Texas in Austin. So the students who have joined has the great opportunity to hear a great teacher. And thank you very much. You told about the examples you have given. That will give a lot of input to the startups who are coming up in India, because you have given through like digitalization, then artificial intelligence, then smart contract, how to organize. So this will definitely help the participants. And I again thank you very much for joining us, the Mining Engineer Association of India. And we will be looking forward to for your further associations. Thank you. I will now invite the next speaker, who is from the great country, Brazil, known for its iron ore mines and throughout the world, and also the beaches. Mr. Victor Chavez, he is the founder and CEO at Rio Analytics. Rio Analytics is a member of the Cohort 2020 of Prospect Mining Studios. Cohort 2020 is a group where a lot of startups interact with each other. And about last year, I heard about some 2019, some 15 startups were together. So he is also a member of Cohort 2020 in the Prospect Mining Studio. It is a technology company focused on development of artificial intelligence, which I think this webinar is much more on artificial intelligence, digitalization, and application to predict failures. Combining advanced industrial analytics and artificial intelligence, Rio Analytics developed a digital platform capable to predict failures, which in tandem with Mr. Sunil Bedula's also presentation. Applying real-time artificial intelligence like predict failures, optimize performance, and increase asset service life. As our mining industry in India is mostly in the remote area, and physical examination of uh, each equipment and also the skill level may not match. So your approach as a startup, or if we do it in India, it will be very helpful to us because we will predict failures and also increase assets life. So now I invite Mr. Victor Chavez for his presentation. Please, Mr. Victor Chavez, over to you.
Thank, thank you, and yeah, 100%. Yes, actually, as you're gonna see on the presentation, there is no like a bulletproof on this failure prediction and predictive maintenance. So why is so important to have complementary solutions as the one developed by NanoPrecise and what we are doing. So it's gonna be very nice to present what we are doing here for you. I'll share the screen if you could confirm. So presentation here. I'm Victor. I'm the CEO of Real Analytics. I started the company in 2017 after working like for more than 10 years in the R&D department for an oil and gas company. I have a master's degree in neural networks for the Federal University of Rio de Janeiro. So, and then our main goal here is to predict failures of industrial assets using the available machine learning, deep learning tools we have today. So we are really focused on this big problem that is downtime. We are not doing anything related to energy efficiency, process optimization. Our main focus exclusively is to predict how, why, and when our equipment is going to fail. And then we know that this is a nightmare when a pump, when a compressor fails, and this was not expected, is a nightmare for mining, energy, offshore, refining companies. Just 1 second that I'll start here, the time. And we have this $1 billion question. So when a pump, when a compressor, when a valve fails, could you have prevented this and predicted this? And the answer yes. That's why we developed our platform called Kairos, where we use real-time sensors from these equipments, and we combine with machine learning, deep learning algorithms to generate predictive alarms for how, why, and when that equipment is not working as 3 months ago. So why the pump is not working as 1 month ago when I did a proactive maintenance routine. So and then we're gonna see here that we in order it was we choose to use in the existing sensors because we see that there is a lot of value of on the existing sensor on this equipment. Of course they are there for more process purpose, so it's easier for us to use this sensor, but there is a limitation on our failure prediction. So what I tell to my team and to the client, we have like a big compromise of scalability and accuracy. So more we are able to develop more scalable and agnostic algorithms, more we're gonna lose the accuracy of the system. And more you focus in one equipment to develop that algorithm or that IoT system, more the accuracy you're gonna have, but you're gonna lose in terms of repeatability, scalability. So there is a compromise there. That's why it's so important. There's a much value on the existing sensors on this equipment, but is a lot of value on put more sensor like accelerometers to monitor the RPM and speed of this equipment. So combine it, the process variables that are already existing with the new IoT system, you can create a very, very powerful system for failure prediction. So our main value of the company, of our technology that I'm going to show you there, is how we combine machine learning and deep learning algorithms with the equipment physics and mechanics, how we combine our knowledge and mechanics with the AI algorithms. And then we develop a digital platform. that is on the clouds to deliver this solution to our clients. So on these 3 years, we developed this concept of library of failure prediction apps. So we didn't want to be a consulting group in the beginning, right? For a new project, a new modeling, a new AI algorithm modeling. So this is something that is very painful. Sorry guys for the noise. This is very painful. So from the beginning of the company, we developed this concept. So all the algorithms we develop, it can be used for any type of equipment. So we just change the variables that you're gonna use, as I'm gonna show you later. So and then this concept of library and then using the same algorithms for doesn't matter the equipment, give us the ability to be equipment agnostic and to have a scalable AI flow, to not wait 6 to 3 months to deploy AI solution. With our solution today, our technology, in a few weeks, we can put in place a failure prediction with very deep learning algorithms behind it. So, and of course, more we are agnostic, there is a compromise on the accuracy. That's why it's so important also to have IoT sensors. But with this our approach is to develop a tool that can be replicable in a mining sector for a pump, for a conveyor, for a compressor, for motors. So, and then our strategy is to be as much scalable as possible. And then, of course, there is a compromise on the accuracy and the individual behavior of each of equipment. So that's why, as I talked before, there is no bulletproof. It's always a combination of existing solutions. So as you can see here, we connect our platform in existing database and automation systems and other data sources, as you're gonna see. We started the company using time series from sensors, but as on the previous presentation, today we are using a lot of report, inspection reports that we're using natural language processing to process this data and take insights from these texts and reports, and that is in PDF, in Excel. So today we have a very good tool for time series, but also for non-structured data. And then we are an AI and software company. So we don't touch on the sensor side, on the IoT side, as I mean, we need to have focus. So we have companies like NanoPrecise that is doing a very great job on this IoT and also on the software that is very complementary with what we are doing. So going deeper on the technology, so we have a lot of engineers here in the room, so we can go deep in our strategy. So as we usually, we don't have a failure data history from the client. So today is a big utopia that the mining company, we're gonna have all the failure data history from the pumps, from the conveyor, from the motor. So this is impossible today. Maybe with our platform we'll be able to do in the next years, but today we don't. So we decided instead to try to model the failure behavior, we go and then we model the healthy behavior of the sensor variables we have. So it doesn't matter which is the equipment, if it's a pump, a motor, a wind turbine, a compressor, a steam turbine, a steam boiler. We know based in our engineering lodgement what is the variables that we need to look for. If it's a pump, we know that we need to take a look on inlet and outlet pressure. If it's a wind turbine, we need to take a look on the power generator. If it's a compressor, it's outlet pressure. If it's a centrifugal pump, it's going to be pressure. If it's a displacement pump, it's going to be torque and displacement. So depends of what the equipment, we select the variables that we're going to create what we call the virtual sensors. So we use Bayesian neural network to create this transfer function of the healthy behavior. So we put as input all the variables we have in the process, 100,000. And then we use a trained neural network to predict what should be the healthy behavior of an output sensor. So it can be the pressure, if it's a pump, temperature, if is the valuable variable is the temperature, the flow. So, and then I tell everyone that the high and low alarms is gone, right? The era of this type of static alarm is gone. So we see the technology emerging that we can be, I mean, we can do something more, right? Doesn't matter. I mean, doesn't mean that we have a pressure, a peak on the temperature that your equipment is failing, right? So depends also of the variables that is inputting your system that is changing. So maybe you're gonna have a high temperature if if your fluid is very viscous, right? Doesn't if the outlet pressure is very high. So this is not a point, right? So the high and low alarm is good to trigger the operation, but is not a good indicative of the healthiness of the equipment. So based on that, we create this concept of virtual sensor and creating a dynamic confidential interval that is the shadow one. So the shadow one is predicted based on our neural network. And then we can create like a dynamic confidential interval instead to have a high and low alarm. So going deeper on this. And then we have a strategy, also strategy that when we want to compare two time series, so depending if it's a centrifugal pump, we want to compare an outlet pressure with inlet pressure. And and then when you do this comparison, we don't have to have the failure data history. So this matrix profile algorithm is being used for financial, stock option, stock prediction. And then we are able with these arguments and using in the example of this pump, comparing inlet and outlet pressure, even don't having the failure data history, we can check the anomaly between these two time series. So this is a good example. So all these arguments that I'm showing you is already being validated in our clients that I'm gonna show you there. So I hear a little bit of what we are doing in terms of, okay, each time we identify a failure, we create a database with this failure. And then during the time, we're gonna be able to create this network concept, like more equipment diversity we're gonna have, more failure modes we're gonna have in our platform. We're gonna train our AI with better accuracy, and then we're gonna retrofit benefits for the clients. So, and then of course, this is gonna be done during the next years. And then we'll be able to, to compare brands and manufacturer, why a G pump is not working as a ABB pump. So we hope on the next years we're gonna be able to this. And then during the time we develop a technology and a platform that can be used daily for the maintenance team. So of course, failure prediction, diagnosis, but also report management, how they do this. Instead to do an Excel writing, they can put this in our platform. Of course, this is not high tech, but it's very useful for them. And then we are putting inspection features. So when they do the inspection, what's the results? We are putting some analytics on these results. And of course, how they use the lubricants, what is the service life of the lubricants, and what type of lubricants they use, and if increase the failure prediction rate or not. So today, Kairos is being used as a broad perspective, not just on time series processing for the from the maintenance team. So we have this case on the CAP. So CAP is a mining company in Chile. So they have an iron ore mine. And then we did a pilot with them for this pool pump. And then this pool pump is critical because they push the mud of the iron ore through the mining pipeline. And then this is very critical. And then we are able on these 3 months of operation to reduce 30% of downtime. So the main objective here was to avoid and told the operation team why this pool pump is not working as 1 year ago, and then why is happening this and how this is going to happening. So I didn't put on the slide, but instead to use neural network, we use decision trees to identify the root cause analysis of what is the sensor that is impacting more the failure we predicted. So this is the same case, the same methodology, the same algorithms, the same workflow that we use on the mining, we use on the on this oil and gas application for BP. This is a sensor application that we apply, is a flow meter.
5 minutes more.
Okay, okay,
Thank
thank you.
you.
So this is another one that just showing that how diverse we can be. So we use the other sensor from the gas pipeline to predict what should be the result of this flow sensor, and then we are able to detect miscalibration detection of this flow sensor that is very expensive. So steam boiler is very used for cogeneration, also in energy, but also in mining. So the same methodology we applied for the pool pump, we applied for the sensor installed on this steam boiler complex here in Brazil. Just a little bit about the company. We started in Brazil, but today we started our international expansion to Toronto in Canada. We are participant of new leg program that we are doing pilots with 2 mining companies with them, and then our main goal was to attack and be part of USA and Canadian ecosystem for startup, as was mentioned before, that is very related, and how we're gonna grow in the next years based on this movement. Our team, so we are 15 people today, so coming from Siemens, Technique, my previous company, Linneo, our AI leader, studying in Cambridge. So today we are a mix of mechanical engineer and AI and data scientists. So I'm very proud of our team, by the way. We are doing amazing stuff even on this pandemic period. And that's it, actually. I will not use like my last minutes, but thank you very much. I hope this was useful on the technical side a little bit, on the case studies that I mentioned, and also how our technology is complementary of the existing one. That is very important, right? Thank you.
Thank you, Mr. Victor Chavez. It's a very interesting and insightful presentation. The last slide where you have seen the photographs of your colleagues, is all are young, and I think this will inspire the young participants who have joined, that startups are for them, and startups can make them an entrepreneur, and their hard work they can turn into a big success, which you have seen now in our webinar.
And then also in based on the history of Sunil, right? Sunil comes from India, so he can be a very great inspiration for everyone.
Yeah, very much. And I will add to that, there is no limit to increase the efficiency by cutting down the machine failures. This can be strengthened by your proposal, your concept of creating a failure data history and analyze them with for increasing the machine operating life. You know, Industry 4.0 is also aiming towards that, and the concept also gives a lot of inroads to this type of collection of data and analysis of them. And that Industry 4.0 is already made an entry to Indian mining industry. And I think your presentation, along with other presentation, will definitely inspire the mining industry go for in whole hug for Industry 4.0. Thank you very much for this such a brilliant and insightful presentation. And we will move to now the last but not the least, the great presentation we are expecting from Mr. Anirudh Reddy, who is the CEO of Einstein USA. Anirudh Reddy is a graduate in civil engineering from Stanford University and founder of Insight, a startup leveraging artificial intelligence and IoT to track the boost productivity and construction of mining sites. Insight uses real-time data from cameras and sensors that are installed on heavy machines and plant to generate actionable insights that help CEOs, managers, operators to run their sites better. Mr. Anirudh has also built and deployed an industry-leading project and equipment management platform to manage a very high value, mostly about 9,000 crore of highway construction project. He's from a family of business of construction houses from India, presently in USA, doing his work there. And I invite Mr. Anirudh Reddy. And I must confess that it is a very odd time for him. And he is in San Francisco, and perhaps it will be about 7 or 7:30. So, in spite of that, he has agreed and come forward to give his presentation. We are very much thankful to Mr. Anirudh Reddy. Now, over to Mr. Anirudh Reddy. Thank you very much.
Thank you, Dr. Nanda, and thank you, Sushil Kumar ji, for this opportunity. I think seeing the presentations from some of our earlier panelists, I feel that I am definitely in good company because it's some really amazing work that is being done globally. And it also has put the pressure on me to close with a good presentation because all the earlier presentations were really insightful as well as engaging. So let me hope that I can continue in the same vein. Thank you. So as Dr. Nanda had just mentioned, what my startup Einsight is doing is trying to bring analytics into the mining and construction industry using AI, or what we like to call machine vision. And so as a company, we're trying to bring machine vision and analytics to the mining and construction industry. So before we go into the details and the slides, I'd like to start off by just giving you a quick visual snapshot of what we do, what we mean by machine vision analytics, since it may be a new term for some of you. And this is a quick video we made in one of our sites in India, actually. And it is an open pit mine where we have where there are several excavators operating to remove overburden as well as to do the actual mining activity. And what we have seen as a consistent need across different types of customers is the big open question on how individual machines are performing in the field right now. Because what we have seen is that there are technologies and sensors available to tell you the machine uptime, to tell you their utilization, to tell you their fuel efficiency. And also, people have tried putting sensors into the buckets to measure the weight of material moved. But what we found is all of those different systems don't actually tell you the productivity and efficiency of how the operator is performing right now. So this is the big question we wanted to answer. If you look at a machine operating in the field, we want to know how the machine or the operator is performing at that moment. And what we are bringing to the industry is what we call machine vision analytics, which involves using, of course, the machine which is doing the work, but adding a camera and providing vision to it, and then bringing analytics through AI. So I'm just going to pause here so I can explain to you how exactly this works. So what you're looking at right now is the video stream from the camera itself on top of the cab so that it can see what the operator is seeing. And we also use cameras that have a 180-degree field of view so that the camera can see in a very wide view everything that is, all the relevant activity that is happening. And through this video stream, we actually run our computer vision algorithms, which we have built. We start by detecting all the relevant objects in the frame of the video. So in this case, as you can see, there's a truck being loaded, and then there's the bucket. We, of course, also do other techniques such as key point analysis. You'll see these red dots here, which also analyze not just the object itself, but the orientation of that object. Is the bucket scooped, curling up or curling down? Is it picking up material or not? Identifying the interesting objects in a frame, and then by tracking how they move and interact with each other, we start to build an understanding of what the machine is doing in the field. And in a way, this kind of mimics the way that humans also understand their environment. Right? When you're a child, you don't know anything what you're looking at, but over time, you start to recognize certain objects. And based on the movements of these objects, your brain tells you what is happening in the world around you. And so that is the kind of understanding that we've tried to mimic and replicate. Now, how can that be used? So because we're able to do all of this analytics inside the cabin itself, we're able to show the results of our analysis in the form of metrics to the operator in a tablet in real time. And in, sorry, the video keeps starting again. In addition to that, we also allow managers to look at all of these videos with all the relevant metrics and context attached to it, so that they can understand how their team is performing and make better decisions. And on a much higher level, what we're trying to do is to try and bring in intelligence into what I like to call dynamic industries. So if any of you have, spent time in other types of, manufacturing industries, any kind of manufacturing, oil and gas, I think, or even the power sector, what you'll realize is most of the machines that are driving the production of that industry are actually fixed in the ground. And for the most part, it is kind of a fixed process that gets repeated again and again and is very efficient. And in most factories today, you also see a SCADA type of system where you have sensors outfitted onto all the relevant machinery, which also helps you control and track all the parameters. And you can nowadays you have even a 2000 megawatt power plant, 2600 megawatt power plant can be run by a team of 20 or 30 people sitting in a control room. Unfortunately, the industries that we are looking at, which include mining and construction, are much more dynamic. So the machines that are doing the work are never in the same place. They're always moving. And the site itself is changing and evolving. So what we believe is that one of the reasons why the mining and especially the construction industry has been lagging behind in productivity compared to some of the other manufacturing industries is because of this high complexity, variability, and dynamic nature. And what we believe is instead of a SCADA system in a static factory, we need a more dynamic system like what we are developing to be able to track the real-time productivity of the machines that are driving the work in these industries. So a quick background on our team. As Dr. Nanda had mentioned earlier, I'm from a construction family in India called Gayatri. And I had studied civil engineering at Stanford and then spent a few years actually building a complete end-to-end, almost like a digital ERP system for our family business to be able to run and operate their sites more efficiently. That's when I realized the big need to track the productivity of the individual machines, especially in a sector like mining where the machines drive pretty much all the work. Apart, of course, apart from me, I have a huge team that is supporting us and is very qualified. And I'm very lucky to have a team with such a diverse but also relevant experience. So people on our team, for example, have been in the founding of companies like Matterport, which was one of the pioneers in digital, 3D modeling of buildings. I also have people who have worked in the early days at Trimble, at Airware, Autodesk, and have a lot of experience in bringing technology into these very difficult environments, such as construction and mining. So again, some of the questions we're trying to answer, or some of the things we're trying to improve is how the site is managed overall. So despite all the improvements in mechanization of machines, even today, what we see is that a lot of sites today are managed on paper. What I mean by that is, the data that is collected from the field is in the form of paperwork, which may then be translated into a digital ERP system. But the actual data collection itself is limited by what an operator can fill into his trip sheet or his time card, or a manager can fill out in his daily progress report. And what we want to change is to make the entire process digital and as automated as possible, so that anyone on the project would be able to look at their smartphone or their computer and get, again, actionable insights about how their site is performing. So The goal with the reason we want to automate some of this data capture using these cameras and sensors is because that's the only way that we can really speed up the feedback loop. And so this is a pretty common concept that has been discussed in the US. But the idea is that a lot of the traditional industries suffer and do not improve as much because they're not getting the quick feedback and improvement cycles. And what we are hoping to do is by directly getting the status of the project from the sensors that are on the machine, and if Einsight is able to provide that feedback back to the machine operator in real time, then people react to the information quicker and continue improving and improving. And again, this slide gives you a sense of, this is the camera, that's how it is installed on the machine. And the analytics that I had showed you in the video in the beginning of the presentation. And of course, the insights can be delivered through multiple formats. You have a web app which you can managers can use in their office. You have a tablet that it can be installed in the machine itself, and you have mobile apps that people, anyone on site could, or anyone in the company could look at to track what's happening. And the idea is to track both the productivity or production as well as metrics related to the costs and cost efficiency. And the reason we want to do that is we want to be able to boost profit. And so let me explain to you some of the numbers here on this slide. This is a general kind of ROI estimate that we have discovered through some of our sites. Most of these open pit mining projects that we're talking about, most of their costs that are involved are actually the machinery and the cost of operating these machinery. Right? So for example, if you have 20 excavators on a site and you're producing a certain amount of material production per day or per month, that what your top line is, your revenue, and then your costs are the cost of buying or leasing or renting the machines, the cost of filling them with fuel, and the cost of the operators who are running it, and finally the maintenance. So what we have seen is that using analytics to reduce the costs, such as the fuel cost, might have a 20% or so boost in profit. But if you're actually able to increase the production itself, then the profit boost is much higher. Great, if basically for every 10% production boost, we've seen more than a 50% boost in the profit margin. And the reason for this is that, again, as I said, all the costs involved, most of the costs involved are related to the machines. So if we can show a customer how they can use the same 10 machines that they have to produce 10% more material, given the same number of machines, same amount of fuel, same number of shifts worked, then you are increasing your revenue without increasing any costs. So that's why that increased revenue goes straight down to bottom line and has a very big impact. So here are a couple of examples that we have seen in the field on how we can use the data that we're getting from our system and how we can provide that back to the customer as an insight that they can act on. So one of our customers in the US said that the big problem they're facing is the lack of quality in the operator output, because they're seeing a huge variance in the performance levels of various operators. In fact, they told us that the one operator, their best operator, is twice as good as most of the others in the team. So what we did is, once we put our cameras on these machines and start collecting the data, first we're able to actually measure what that productivity is. So we saw that one of the operator is producing twice as much material. And what I mean by producing twice as much material is he's physically moving more material and loading more trucks in the same amount of time, right? More tons per hour produced, or more cubic meters per hour produced. So when we wanted to understand, like, why is it that one person is able to do so much more in the same amount of time with the same machines, we looked at some of the other data points. So one of the key factors we saw was the swing angle and the bucket fill factor. So a swing angle is essentially, if you look at this excavator, it picks up material from, where the material is available. or from a stockpile or from the mine face, and has to twist around to load it into a dump truck. And depending on how the operator has positioned himself and the material, that angle can be very small or it can be a lot. And the smaller the angle is, the quicker it can move back and forth. And what we have seen is that the best operators, while they're waiting for the next truck to arrive, actually use that time to move material closer so that they reduce their swing angle, and that increases productivity significantly. The other very easy thing to realize is how good the bucket fill factor is, where the more experienced operators make sure that as they're picking up the material, for every scoop of material that they drop into the truck, it is a full bucket, and you're not wasting time going back and forth with half empty. So when we were able to show this, not just in terms of numbers, but also in the videos to the operators, we're able to explain to them and try and train them on how they can improve. And the operators, some of them do, some of them don't. It takes a while for them to really understand and incorporate these changes. But for every improvement in productivity, as I said, it goes straight to the bottom line of the customer, which is why I think the customers are so eager to roll out this product onto all of their machines. That was, an example that showed the performance levels of individual operators. But for some mines, it also yes,
Mr. Anirudh, 5 minutes more.
Thank you. So for some operators, also for some sites, it also depends on how you allocate your resources within the site. So this is another customer. They have a mine face with excavators, and then they have a large stockyard where they load customer trucks with front loaders. And currently, they had, say they had 5 machines. All 5 of these were, at the same level of utilization. So they thought that the site is very productive, and this is how we're performing. But what we started to notice is that the production or the productivity or the revenue was lower than what they really wanted. So once we analyzed the productivity rather than the utilization of these 5 machines, we realized that the excavators were performing at the peak of their performance level, but the front loaders were, even though they were moving around a lot, they were not really at the high level of productivity they could be. So when we recommended, for example, to move one of these machines to the mine face, we realized that you could increase the production at the mine face, and then in essence, you would have more stock to load up to customers, and that increases the delivery and the revenue of the site overall. So this is an example of how machine allocation can be used to improve the productivity of a site. And this is something that's always evolving because the site itself is evolving and the weather and the other external factors are evolving. So we believe that our system can continue to show improvements and insights by getting real-time data from each of the machines. So right now we are in the process of, collecting this data, showing them some reports and videos, but also we have an industry expert team in India who analyzes all of this information and makes recommendations. What we're now working on over the next year or so is a way to collect the data points, compare them to the relevant metrics or thresholds or ratios, and then perform an analysis on that so that we can automate the recommendations based on just what data comes in and what are the benchmarks that have been set for that site. And I think if this happens, we're able to start providing recommendations, not just at the end of the week to the manager, but to operators in the cab itself. And we hope that this kind of a system continues to shorten and improve that feedback loop. So eventually everyone on site can look at a screen to figure out, okay, this is how I'm doing, this is my goal, this is how I can improve my performance and reach my goal. And hopefully that creates a continuous cycle of improvement. So that was all that we had today. And I'm happy to take any questions during the Q&A session. Again, thanks a lot for the opportunity, and I'm glad to have presented at this webinar today. Thank you.
Thank you, Mr. Anirudh. It's a, you can say, very brilliant presentation and engrossing. I can say it's a very engrossing presentation, because for the first time, I missed to give the alert by 2 minutes. When you were explaining how these trucks were to be assigned and how these have to be, the productivity has to improve. And I agree with you, your insight that low productivity is a major issue in Indian mining industry, because if you analyze the utilization percentage of mining equipment, it is very low, and all efforts are being done by everyone to increase the low productivity. And your presentation will give them an hand how to get it done. I think we did not multiply the number of equipment to increase the production. What you said, it is rightly said that you increase the utilization, so that you increase your production with the same number of equipment, same investment. That will reduce your cost. So I think the participants are highly benefited by your insight of this malage which is happening in Indian mining industry, low productivity. And that one more thing you told, that the swing angle explanation. That means the quality of operation is also in an area which needs improvement, and this leads to an area of skill development. And I think the skill development in mining is improving in India, I must say, but it has to go a long way. With this, we again thank you, and we also thank you for your very difficult time of the morning you have joined. Thank you, Mr. Anirudh Reddy. And now I will invite the main tank, or you can say the man behind it, this webinar, series of two webinars, Mr. Sushil Kumar, the chairman of Mining Engineer Association Hyderabad chapter. Mr. Sushil Kumar.
Thank you, Dr. Nanda. I think you have taken my 3 minutes out of my 10 minutes, because we have been doing all the, summing up after each of the paper has been presented. So I have very little to really, sum up, but still I'll do my best in whatever manner I can really present. It's okay. Yeah, before I really conclude and also sum up, I just want to project this slide. Parallelly, now Honorable Prime Minister has inaugurated RISE. RISE is Responsible Artificial Intelligence for Social Equipment, Social Empowerment, sorry. So this is the one where it is parallelly being run today itself from 7 to 9 p.m. on October 5th, that is today. And it is there for 4 days, 5th, 6th, 7th and 9th, 8th and 9th. It is, so I think it is, giving a projection that the digital India has to be really improved upon, wherein the relevant speakers have really given insight of everything, where I think the starting, from the starting onwards till the last speaker, everybody has given a 3D view that can be really visualized by either the participants or the speakers and also the policy makers who are there. I'll just sum up the last time and also this time what were the presenters then and now. On 23rd, actually, a similar topic was taken for the eastern part of the world, wherein the countries which were covered were India, Ireland was also there, Ethiopia, Malaysia, Singapore, and Australia. So these were the countries from where the speakers also came. Australia, Jan Verbuman was there, and Sundar Singh from India, Arjun Jananand, Biplab Chatterjee, and myself. We were the speakers in the last thing. So this time we wanted to have the western part of the world to be covered for technical inputs that can be given by the western part, so that we can recommend to Government of India to make as digital mining in consonance with this digital India, which has been inaugurated today by the Honorable Prime Minister, between 7 a.m. to 9 p.m. That is today itself. And today's webinar, the countries which have been covered are India, Canada, US, Chile, Ireland, Ethiopia, Indonesia, UAE, and Mozambique. So these are the countries where the participants were there. and the technical presentations were made by really from Canada, the Chile, then US, two, and one from Brazil. That is Mr. Victor. So I'll just sum up in a very, short manner, and then we'll see how the presenters made an excellent presentation in really visualizing the problems, giving the solutions for each of the things by having the case studies made available. And first of all, coming to Mr. Sunil Vedla from Canada, he has given the failure rates initially, and then issues and opportunities as per industry leaders, then what all can be monitored by the industry, machine doctor, and then nano precise platform, and how are they different by citing factual examples. This also was made. Route-based monitoring and also value of automation, software comparison with examples culminating in the product proportionate value, case studies in mining also was given by him, and then finally how nano precise is different in achieving the quality and value to the customer was also really spelled out by Mr. Sunil Vedula in his presentation, which really gave insight of everything for a startup person to take it forward. Now, coming to Mr. Petrels, I think he has really given an end-to-end solution on a, how a startup really can examine into the parameters that can be really having the problems, how to go about having the solutions for that, and take up that as a career. I think this really will boost the youngsters who are really coming out of the colleges, and then see that the startup innovation techniques in the startups can be had both technically and also the physical results to be given by startups to the mining industry. And here, innovation startups which are covering the entire gamut, how the startups have to find their way by having checks and balances. I think this was really a fantastic thing that Mr. Petros has given, to really how cautiously a startup person has to really look into and then take up this as a profession. In the sense, the startups have to really acquire the latest art of technology along with the implementation of IT, IoT, and also artificial intelligence, and then having the revenues to be generated by the mining industry by cutting costs. I think, in essence, the entire presentation which was covered by Mr. Pedros is giving this holistic view of how a startup really can take up this as a profession. Coming to Dr. Srikanta Mishra, I think this is really, in continuation to Dr. Pedros, he has again given the outline, the definitions, the key characters, digitalization, ecosystem, key digital themes, which have been really explained by him as a professor to children who really come to class and learn the things. And then with real-time cases from oil and gas startup examples, outlook for mining sector also was given explicitly. Key takeaways was really a very good examples that has been projected. Then the main point was the Gartner Hype cycle has to be really kept in mind by all the aspirants who want to take up the startup as a profession, because as the curve was explaining, really within 5 years it has gone up and then it is coming down, and it has a parallel level of line that has been shown to the x-axis, which has to be kept in mind by the startups in order to really go along. Yeah, Mr. Victor from Brazil really given this particular artificial intelligence platform, projected the problems pertaining to mining, refinery, and offshore, along with the solutions. Value proposition with the technology, explained about the company's non-failure with the examples to the clients that was also given. Exhibited networking, Then offshore and energy aspects as well as dealt with the solutions. I think that is the precise thing where they have given their examples, that is how to cut costs, the cutting the cost, and also increasing the efficiency with their precautionary measures that can be taken up by giving the examples of pumps, motors, etc. And this is really, Mr. Victor also gave the insight about the uh, artificial intelligence that can be really used in giving the technology all the input for the solution that can be arrived at. Coming to Mr. Anirudh Reddy, I think because it's the latest, presentation that has been made, he has really given the 3D view that as it is sitting in the shawl and then moving about and giving the example that how the swivel can be done, which has been covered by Dr. Nanda. Mainly, the points that he has covered in this are low productivity due to high variability and also complexity, and how are they managed and actionable insights also. Ancient works that I have given, which with the examples. Project multiplies, that is profit multiplies, sorry. So the profit multiplies, which he has given about the 10% of the thing, and then maintenance, and then 20% increase in profit, and also 10% production versus the 50% of profit that can be made. So these things really give insights for the youngsters to take up this as a profession. How customers act on insights also has been very explicitly stated about the results of that. Automating recommendations really were very good to go in for the productivity on the higher side by cutting costs and increasing the finances to the mining industry. And ultimately, the technology which has to be used was told by him in a very, very vivid manner. It really gives boost to all the youngsters who are watching this particular webinar, will have the insights of both Eastern world and Western world, which covered everything. And then we as a Mining Engineers Association of India will have to submit certain recommendations both on the front of the policy matters and also integrating, as was rightly stated by Dr. Pedros, with reference to the government, the private sector, and the non-profit organizations like MEAI should get integrated so that we really have the proper policies that the government can encourage the startups in implementing their techniques to the mining industry for better results. Thank you. Thank you very much.
Thank you, Mr. Sushil Kumar. Very warm, you can say, sum up at this late hours of the day. I think now we have reached the last part of the webinar. I thank all the speakers and now invite Mr. Dr. Narsimulu, who is the Secretary of MEAI, for a formal vote of thanks. Dr. Narsimulu.
Respected President, MEAI, Sri Sanjay Patnaik, past President, Sri B.S. Rao, Fasiuddin, T.V. Chaudhary, Victor Kotariji, and Sri Sushil Kumar, Chairman, Hyderabad Chapter, and eminent speakers from abroad, delegates and members of MEAI. It is great honor to me to propose the vote of thanks to all participants for making this international webinar great success. I, on behalf of MEAI Hyderabad chapter, extend my vote of thanks to all participants, delegates, and members of MEAI who blessed this webinar. I would like to thank Sri BVR Sushil Kumar, Chairman Hyderabad chapter, for making total responsibility for conducting of this international webinar with coordination of senior members of MEAI. It is my privilege to thank Sri Sanjay Patnaik, President MEAI, and Sri Narsaya, SG MEAI,
for immediately accepting the proposals of Hyderabad chapter for conducting of this webinar. I also extend my thanks to former presidents for their support in conducting of the webinar. Dr. Nand, I would like to thank Sri Dr. Nanda for beautiful modernizing the program, running the webinar smoothly and effectively. I would sincerely like to thank Mr. Sunil Vedula, CEO and founder of Nano Precise Sci Corporation Canada, for his presentation on practically realizable value of automated predictive and prescriptive maintenance of mining sector. Thank you very much, sir, for joining from Canada. I also like to thank Mr. George Pedras, President of Mining Policy Commission of Institute de Indigenous de Chile on startups from a dream and hope to public policy. Thank you very much, sir, for your enlightenment on the subject of startups and joining from Chile. I further place my sincere thanks to Dr. Srikant Mishra, Senior Research Leader, Bartle Memorial Institute, Columbus, USA, for his knowledgeable talk on role of startups in the oil and gas digitalization ecosystem. It is really useful for ambitious people who wanted to set up the startups, sir. Thank you very much, sir, for joining from USA. I also extend my thanks to Mr. Victor Chavez, CEO, founder, Art and Analytics, Brazil, for his presentation on applications for predictive maintenance in mining and oil and natural gas industries. Thank you very much, sir, for your wonderful presentation. I also uh, sincerely thank Mr. Anirudh Reddy, CEO, Insight, for his presentation on mission vision analytics to boost mining productivity. Thank you very much, sir, for beautiful presentation and sparing your time. I also, finally, I like to thank Mrs. Santella for uh, arranging the webinar without any interruption. I once again thank you, Sri Sushil Kumar sir, for his overall summarizing the proceedings. I also thank once again to one and all. Thank you. Thank you very much.